Good morning, everyone. I probably need to stay here. I'm going to talk about, in the next 20 minutes, about the promise here. As you can see, our motto is realizing the full potential of every battery, and how, in practice, we use artificial intelligence to push energy storage into new level. So we live now in a world where we are very dependent on batteries, but if we imagine, say, an electric vehicle, whenever the electric vehicle runs, it comes to a point where we are not very satisfied with the performance of the vehicle. It can no longer run for the promised 400, 500 kilometers per hour, and then we say the battery is dead. So is it really dead? It just cannot fulfill its application in this particular vehicle. So, but the batteries are not just in electric vehicles. The batteries are everywhere around us. There are a lot of batteries, what we call behind the wall. They power the hospitals whenever there is a power disruption. They power the cell towers whenever we want to have a network coverage and in emergency situations. And now we are at an AI summit, and AI is naturally running data centers, so the power horse behind these data centers are batteries. So we can say that the smartest technologies run on top of one of the most old and mature technologies, which are batteries. So our world lives and evolves around batteries. So when do we replace batteries? And do we really trust batteries? So let's say your phone here, you see your battery is at 40%. Is it really at 40%? Do you trust your battery? 10 minutes later, it's dead. So whatever is now measured for batteries, it's almost educated guess. So we try to push this further, and people usually replace batteries when they stop trusting them. And there is virtually no good way to measure the performance of batteries, so you cannot manage what you cannot trust. Sorry, you cannot, with what you cannot measure. So the question, as I started with the electric vehicle, is the battery is not good for the road. We don't trust it for the road, but it could be trusted in many different applications. A battery which cannot go for 400 kilometers can power up a home or a solar system for many, many years. In standby application, that it also can run for a very long time. So the battery is actually not dead. It is mismatched for the application that it was originally used. So how we solve this problem, how we answer this question, how we actually measure a battery if it's dead or not, and if it's good for its application or not. And since it's an AI summit, probably the answer should be an AI. It is not straightforward AI. First, it comes science, and this is kind of a summit that we're addressing, science and artificial intelligence interconnected. So first comes science. This is the fundamental electrochemistry of the batteries. Then we apply the methods on how to measure these batteries. We study these batteries. Then we collect a huge data set of data, and we point the AI to this data. So we're making the AI useful, and AI helps us to do science scalable. So who are we? WaveTech is a company established in 2003. We have a combined battery knowledge of around 400 years. We have several professors. We have a team of PhD researchers. And our technologies are patented in more than 87 countries. We're very proud because what we do is from ideas, we developed IP, intellectual property, and then we developed working products. So I've put a line here, old knowledge, new speed. So we have a lot of fundamental knowledge, as I said, accumulated 400 years, batteries, which is an old science, and we put it into new speed. So all started with how batteries age. What we have, our leading and patent technology is crystal control technology. So with it, we control how the batteries age. There are crystallization processes, recrystallization processes, all the fundamental science inside the batteries. So we tailored charging pulse in a very specific way, and we can control the aging of the battery. So this was the foundation where we started. We saw a problem that batteries are aging, they're dying, so we found a way how to control the batteries during their lifetime. So it's been more than 20 years of science in this field. As I said, 87 patents in 87 countries, so we try to evolve this. When we talk with our customers, they usually ask us the question, is the battery good? Can we trust it? And if you want to characterize a battery and know if it's good, the standard methods usually take a very long time. For example, how do you know if your battery will work? You need to discharge it. So this is a long time. This is, takes a lot of energy. So we developed what is called a battery quality assessment tool, or BCAT, which can read a battery and assess its condition in minutes compared to hours. So this was the first application where we applied AI in order to achieve this. So we gather data from the batteries, we analyze it, we point the AI to data analysis, and we characterize the batteries. When we characterize the battery, we, as I said, realize the full potential. As I said, we believe the battery can live much longer than usually people are using it for. So we developed BARS. BARS stands for Battery Assessment and Rejuvenation System, which is fully automated rejuvenation system, which can bring back to life written off of batteries. So the technology combined with the BCAT, so we first qualify, then we rejuvenate, and we can bring back to life approximately 80% of the batteries that are being used. And after the batteries pass through our qualification tool, we can go up to 95% of the diagnosed batteries go back to life. So how, again, we entangle this into the AI? Every battery is, we collect from every battery around 400, more than 400 data points. So first, the battery is diagnosed. We put it through our algorithms to assess whether this battery can really be used or its life can be extended. Then it goes to rejuvenation, and we collect also the data during the rejuvenation, and at the end we verify the results. So this is a closed loop. All this data is going back and forth, and with every rejuvenated battery we're getting better because our machine learning algorithms learn the data. So we are getting, with every battery we're getting better at identification and diagnosis, if you will, and we are getting better at the actual bringing back to life or rejuvenation. The question is, okay, you do this, how are you doing it? Is it comparable to new batteries? So with one of our clients, one of the Fortune 500 companies, we did an independent test. This is a UPS test, so the difference between a rejuvenated battery brought back to life and a brand new battery in a cycle test, this simulates a life of a battery, is at the end of the test is 0.1 seconds. So this is really where we can push the batteries, we bring them back to their actual service life and actual performance in the field. Around this, we developed, I heard Dell mentioned also AI Factory, so we chosen probably the name very good. We have what we call BARS AI Factory. We don't do AI and manufacture AI there. We rejuvenate batteries at a scale. And we just don't rejuvenate, we don't use the AI only for making our processes better, but we also do analysis. So now, currently, we can do ESG analysis, we can do carbon emission analysis, all types of economic analysis. And just to put the problem into perspective about the volume of how many batteries are being thrown away, perfectly good. Just this year alone, the Turkish telecom operators are planning to swap out more than 500,000 batteries. So most of these batteries currently end up for scrapping, and now we live in a world where the resources are scarce, so we can bring back to life most of these batteries and bring them back to life at half a cost. So let's go back to the AI. So the thing here is that AI is very good when it's pointed at data. Everyone can deploy AI. We now, even as mentioned before, with words we create videos. We have a data set collected based on our knowledge and based on science, where we point the AI. We have such huge amount of data that a human eye possibly cannot comprehend. So we point the AI to analyze this data for us, to search for patterns, to search for similarities, if you will. And this is how it allows us to predict when a battery will fail, if it will fail, and how it is good to be rejuvenated. So with our technology, it allows a single operator to work with a huge amount of data, hundreds of rejuvenation machines and factories around the world. And the AI helps us to see patterns which usually we will not see. So here the punchline probably is too low, but we're powerful not because the AI is clever, because the science is feeding the AI with the exact data, and basically we're asking the right questions, if you will. When we talk about the batteries, now we have established technologies for some of the chemistries, but we're not focused only on one chemistry. We're working, we try to be chemistry agnostic. So now lithium ion is next in our pipeline. It is being in the lab. We develop algorithms further. We educate, if you will, our workhorses, the AI, to analyze lithium batteries. So your phone batteries and your car batteries hopefully will be the next in our pipeline. They're now in the lab, and pretty soon they will be with you. But with that, I hope that you get some idea and overview of how we try to interconnect science and AI by collecting the right data, applying the right scientific methods, and then running it through such a powerful tool like an AI, which can give a lot of insights. Thank you very much for the time.